Okay, so before starting this class opener, especially for these types of questions, that like number 5 that has a fraction, number 4 that has a fraction, and number 6, I want to talk about how to get rid of fractions. So let me just move this to the side here for a bit, and give me any fraction, guys. Any fraction. Any fraction. 2/5. Okay, 2/5. So we have 2/5. Now, what would happen to this fraction if I multiplied it by the number 5? What would happen? You guys tell me what happens. Okay, so somebody said 10 over 5. Yeah, that's true. You could put it over 1 and multiply the top with the top. 2 times 5 equals 10. And then 5 times 1 equals 5. So you end up with 10 over 5. But what's 10 over 5? It's really 10 divided by 5, which is what? 2. So the final answer is 2. So whenever you multiply a fraction by its denominator, I mean, what you could do right there is simply cancel them out, and your answer is 2. Right? Simple as that. So it doesn't matter what fraction you have, 2/7. If you multiply it by 7, what's going to happen? The 7s are going to cancel. Because 7 over 7 is 1. It cancels out, so your answer is 2. Same thing like 5/9. If you were to multiply that by 9, what happens with the 9s? They cancel out. That's how it always works out. I guess it's important to take a moment and say, so we had a good question. What if you're multiplying a fraction by a number that's not the denominator? So like, let's say we did have 2/3. And let's say we were multiplying by 2, right? So right there, obviously, 2 over 3 doesn't cancel out, right? So right there, you do have to multiply, maybe put that 2 over a 1 so it'll look like a fraction. That way you can multiply the top with the top and the bottom with the bottom. And 2 times 2 is 4. 3 times 1 is 3. So that would stay 4/3. It would stay a fraction. Yeah? Cool? So, but the main idea I want to get to before the class opener is if you have any fraction, right? Let's say you had 12/13 with an x right there equals 1, all right? A lot of people get confused with that. Let's say you wanted to get rid of this fraction, you'd have to multiply it by the denominator. Whatever fraction you have, whatever number's down here, go ahead and do this. Put a little times right next to it and that same exact number. That way it'll cancel out. But remember, on an equation, what you do to one side, you have to do to the other side. So you're going to multiply by 13 over here, right? So what we end up with in this case would be 12x equals 13. Now you still have the 12x. So that's really saying, what is that saying, guys? 12, what is that? Plus, minus, multiply, divide, what is that? Multiply. If there's no sign between it, you're multiplying. So you'd have to divide by that same value 12. To get rid of the multiplication, you're going to divide by that same value 12. It's going to cancel. And when you do to one side, you do to the other, divide by 12. Now, a lot of people get freaked out right here. They say, oh, 13 over 12. I can't divide 13 over 12. You're right. You can't do it. So you just leave it. That's your answer. It's a fraction. The answer is x equals 13 over 12. Or you could write it as a mixed fraction, 1 and 1/12. But I'll accept the improper fraction, 13 over 12. Okay, so that's probably as hard as it gets on the class opener. Let's jump to the class opener. And how about I ask you guys to do this on the iPad with the pencil and explain what you're doing as you go. Any volunteers on number 1? We have a volunteer. And go ahead and start solving. What are you going to do?
Subtract.
Oh, I'm sorry. You're going to subtract, okay? Subtract 12 to get the x by itself. And what you do to one side, you do to the other side, so you're going to subtract 12 on the other side, right? Okay. And a -5 and a -12 is -17. You got to think of money, right? So that's your final answer. X equals -17. Thank you very much. So let's say you took a quiz on Friday and you got this answer. Thank you, Chris, for volunteering right there. Let's say you got the answer x equals -17. What does that mean? That means that this x right here is really -17, right? So if you have some time left over on a quiz, you might as well go back to your questions and plug in your answers and see if it actually gives you a true statement. So if I plug in negative 17 right there, it's going to say negative 17 plus 12. Does it really equal negative 5? Let's think about this. Thinking of money, you owe 17, you have 12. Yeah, you're still going to owe them 5. So what we just did right there was double checked our answer, negative 17. So I know that this answer, x equals negative 17, is 100% correct. Okay, so there is no excuse in giving the wrong answer. You could always plug it in and double check your answer. Okay, let's move on to the next one here. Number 2. So what do I do there to get rid of the... You do the opposite, and x is clearly on the left side of the equal sign. It's over here. You want to get rid of this minus 2, so you're going to do the opposite, which is plus 2. So it's like a balance scale. It's off balance right now until you do the same to the other side. That's where the rule came from. What you do to one side, to do to the other side. So that cancels. Bring down the x. You don't have to circle and draw the arrow. I just do that. Sorry. Bring down the equal sign, and then you bring down the answer, negative 11 plus 12. If you owe $11 and you have $2, you still owe 9. So there's your answer, x equals negative 9. Okay? And in your mind, if you wanted to double check this, you could say, okay, negative 9, if I put it right here, that's going to say negative 9, I owe $9, minus 2, I owe $2. I owe 9, I owe 2, yeah, I'm going to owe 11. So you double checked it in your mind right there. Okay? So you could always take your answer, plug it back in to double check. Let's move on to number 3 here. So, see, the goal is always to do what? To get x by itself on one side of the equal sign. So x is clearly on the left side of the equal sign. So we have x right here. We also have a negative 14. We want the x by itself. We don't want this negative 14. So what do I do, Janisa, to get rid of that minus 14? Yep, you add 14 to both sides. So you go plus 14, that'll get rid of it. It's off balance right now. But if I add 14 over here, I'll still have the equality of the equation. What you do to one side, you do to the other. So then you bring down your remaining equation. We have x, we have equals, we have positive 12, and there's nothing else to do. You've achieved your goal of getting x by itself on one side. So there's your answer, x equals 12. Let's jump to number 4. On number 4, we have a fraction. Danielle, how would you help me out here to get rid of that fraction? Thank you very much. You do want to multiply both sides by 9. So because this is a fraction, that's really saying x divided by 9, you just want x by itself. That's the goal. You don't want this divided by 9. So if you want to get rid of a division, you do the opposite of division, which is multiplication. So we put multiplication times 9 times that denominator. Notice that I wrote it up on top. So the 9 cancels with the 9, and what I do to one side, I must do to the other. So I multiply by 9 over here to maintain the balance, to maintain the equality. So I have x equals negative 72. And there's my answer right there. Let's move on to the next one. More fractions. Gotta love it, right? Don't freak out. You're thinking, oh, there's 2 fractions, I'm scared. Don't be scared. You can get rid of any fraction. But let's go back to the goal. What's the goal of this thing? What do you want to do? What's your goal? To get the x by itself, all right? So, Isaac, let's say you wanted to get x by itself. What would you have to do to get rid of the division of 24? To get rid of the division of 24. You want to get rid of the division of 24? How do you get rid of something? If there's a fire, you turn it off with water, right? With the opposite stuff. So if you want to get rid of the division, what are you going to be using? Multiplication. So we're actually going to put a multiplication symbol right here, and it's going to have to be that same exact number, 24. And notice that I write it up here because 24 on top over 24 on the bottom, that cancels out, it becomes 1. But then again, remember, what you do to one side, you have to do to the other of an equation to maintain the equality. So if you multiply by 24 over there, we're going to multiply by 24 over here. And notice that I wrote it up on top as well. So right here, the 24 and the 24, they really do cancel out. The x is left over. Let's bring that down. The equal sign comes down. Now over here, you could think of it as 24 up on top, 6 on the bottom. That's like saying 24 divided by 6. So you could actually cancel those out and get your answer 4, and the answer is up on top. Now, if you wanted to show your work and say, okay, I want to multiply 1/6, Mark, by 24, you could put the 24 over 1 and then multiply the top with the top and the bottom with the bottom, and you'd get 24 over 6. Now, that 24 over 6 is a fraction. A fraction is really a division problem. So what's the answer right there? What is 24 divided by 6? The answer is 4. So x equals 4. So do you have to do this? You don't have to do that. So once again, I want to say that you don't have to put the 24 over 1. You could have just right from this point, you could have said that 24 on top divided by 6 on the bottom is 4. So you'd have a 4 left over up on top, and that would be your answer. But if you want to multiply the top and bottom, go for it. You get that answer, and then you could reduce or divide and get the final answer 4. Now this one here is a little more fun because we have a fraction 2/3. And see, it would be nice if this equation would be nice if we didn't have the divided by 3. It would be nice if it looked like this. If I had a 2x equals -4, that's easy to solve, right? But the problem is you don't have a 2x equals -4. You have a 2 divided by 3x equals -4. So this divided by 3 makes it look a little nasty. Remember, you could get rid of any fraction by multiplying everything by the denominator. So I want to multiply the 2/3 by 3, and what I do to one side, I do to the other side to maintain the balance. The 3's do cancel out. I do have 2x left over. The equal sign comes down. I have a -12 over here. And now I have a nicer looking equation. I have this nice one that I wanted in the first place. I didn't want the divided by 3. I got rid of the divided by 3. Now it really is the 2x equals -12. So for my final step, I have a 2 times x equals -12. So I need to get rid of the multiplication of 2, which would be dividing by 2. That'll cancel out, which you do to one side, do to the other. X equals -6 is your final answer. Number 7, how do we get rid of that -10 right in front? Anybody? You divide by -10 by that same exact value. What you do to one side, you do to the other side. Right here, the -10s cancel. You do have an x left over. There's an equal sign. Now, -5 divided by -10. Could you divide 5 by 10? No, you could divide 10 by 5, but you can't divide 5 by 10. So that's a fraction that you could reduce at the very least. But one thing that we do know is that a negative up on top and divided by a negative on the bottom, that has to be positive. A negative divided by a negative is a positive. So if you think about it, your answer is going to be positive. And 5/10 you could reduce by 5. So you'll get 1/2. Positive 1/2 is your final answer. Some people get confused with this one because it has a minus minus. Anytime you have a minus minus, you have to do what? Positive, positive, right? Change it to plus plus. So this becomes plus plus. You could even rewrite the whole thing if you want. -3 equals 5 plus x. You don't need a plus plus, right? So you want to get rid of the 5. What do you do to get rid of that positive 5? Minus 5, right? So let's subtract 5 here. Subtract 5 over here. Because what you do to one side, you do to the other. The x is going to come down. The equal sign is going to come straight down. -3 minus 5. You owe 3, you owe 5. Eddie, what do you get? -8.
Yeah.
All right.
I was going to say that.
Good. Let's try another one. Again, the minus minus changes to plus plus. And you want to get rid of the plus 5. You're going to go minus 5. That way it cancels out. What you do to one side, you do to the other. 4 take away 5 is -1. You have 4, you owe 5, you're still going to owe 1. The equal sign comes down, the x comes down. You could leave your answer like that, or you could switch it and say x equals -1. Either one of those is acceptable. Let's move on to number 10, final one. We're going to change the minus minus to plus plus. We're going to rewrite it. Next step would be to get rid of the 4 by subtracting 4 on both sides. We rewrite it again. 2x equals -1. -1 equals 2x. And final step would be to divide by 2, which means that our final answer is x equals -1/2.